In Unit 3, we are going to learn capacitor. What is capacitor? A basic capacitor has two parallel plates separated by the insulating material, which is called as dielectric. Capacitor stores the energy in electric field. Capacitance is a property of the capacitor by which energy is being stored in electric field. The unit of capacitance is farad. Capacitance value can be very small, microfarad, nanofarad, or it can be picofarad. What is the construction of capacitor? Just look at the diagram. There are two parallel plates. In between the plates there is a dielectric material. Dielectric material is an insulator. So there is no current flowing through the capacitor. What are the properties of capacitor? Capacitor stores energy in electric field. Capacitor makes change in voltage in the network. Capacitor has a very special property that it allows alternating current to pass through it. It blocks direct current. So it is acting as a filter for DC. Relationship between voltage difference and the charge is normally linear. What is electric field? Electric field is a electric flux. What is electric flux? It is a charge. If you look at this diagram, this is positive charge and these blue lines are electric flux lines, and these circular sections are defined as a area. So what is electric field strength? Electric field strength at a point is a force acting on unit positive charge at that point. Wherever you want to find the electric field strength, put the unit positive charge at that point and see what is the force acting on it. That is electric field strength. Electric flux lines are always from positive charge to negative charge. Electric flux lines never terminate. Electric flux lines are always perpendicular to the area and they never intersect. What are different types of capacitor? It all depends on the dielectric material. They can be mica capacitor, ceramic capacitor, plastic film, or it can be electrolytic capacitor. Electrolytic capacitor or polarized capacitor. When we talk about the capacitor and say that there is no current, then what is the use of capacitor if there is no current? It has to be used for conduction. So conduction current is only because of the property which is breakdown voltage. What is breakdown voltage? Breakdown voltage is a potential which is applied to the dielectric to break the bond within the dielectric and causes the current to flow. Voltage applied per unit length to establish the conduction current in the dielectric is called as dielectric strength. How the voltage rises in capacitor? You see, initially there is no voltage and this is 0. As the time passes, capacitor charges and voltage of the capacitor is settled, and this is called as steady state condition. Time taken to rise from 0 voltage to final time is defined as rise time. Capacitor is fully charged after crossing the rise time, and this is defined in terms of time constant, which is normally 5 time constant. Now we will learn what is time constant. Time constant is multiplication of resistor and the capacitor. So before learning the multiplication of resistor and capacitor, let us learn how the current passes through the capacitor. Current in the capacitor is defined as IC. This is equal to C dV by dt. What is dV by dt? Rate of change of voltage. C is the capacitance. So current through the capacitor depends on capacitance, which is the property of the capacitor, and rate of change of voltage. Capacitors can be connected in parallel and series like a resistor. When capacitors are connected in parallel, C1 and C2 are connected in parallel. They behave as if resistors are connected in series. Same voltage is applied across C1 as well as on C2. Q1 is a charge in capacitor C1. So Q1 is equal to C1 delta V. Q2 is equal to C2 delta V. What is total charge? Q equal to Q1 plus Q2. Q1 equal to C1 delta V, Q2 equal to C2 delta V. So we can say C is equal to Q1 C1 plus C2. When the capacitors are connected in series, same charge flows through capacitor. So Q is equal to C1 delta V1, Q is equal to C2 delta V2 because same charge is flowing. Voltage across C1 is delta V1, voltage across C2 is delta V2. So we can say change in voltage is equal to change in voltage in C1 plus change in voltage in C2. C1 is equal to C1 is a charge on capacitance and delta V1 equal to Q upon C1 and delta V2 is equal to Q upon C2. Ultimately we get the formula as 1 upon C is equal to 1 upon C1 plus 1 upon C2. If you analyze these two equations, we will say charges in series as if resistance is in parallel. Charges in parallel as if resistance is in series. So it is easy to remember the formula when capacitors in parallel and capacitors are in series. Let us see how capacitor stores the energy. This is a parallel plate capacitor. Charges are plus Q and minus Q. We are trying to change the charge by dq. Now when we put some charge near it, there is an opposition and this opposition is shown in terms of energy in the capacitor. So when dq charge is added, there is work done per unit charge which is defined as potential. So delta V is the potential. This is a small change in energy du. This is equal to dq multiplied by delta V. What is delta V? Q upon C. So we can say delta U is equal to integration of du, or it is ultimately U is equal to Q square by 2C. So energy is stored in the capacitor or energy on the capacitor is defined on charge or it depends on capacitance. How the energy is stored in capacitor? Let us learn with the help of this diagram. This is a line which shows how the voltage rises in capacitor. Voltage rise in capacitor is exponential rise. As the voltage is 0, it is behaving like short circuit and maximum current is passing through the capacitor. As the voltage increases, its current decreases. Capacitor is fully charged here, current is 0 here. So how can we define the power? Power is always defined as a product of voltage and current, and this blue curve shows as the power stored in capacitor. Area of this curve is the energy stored. Mathematically, energy stored is defined as half CV square. Now let us come back to what is time constant. Capacitor always charges or discharges through the resistor. Time constant is defined as the product of resistor and capacitor, and this is also called as characteristics time. How the capacitor charges? E is the voltage which is applied in the combination of resistor and capacitor. As I said, capacitor charges or discharges through the resistor. So resistor has to be there in the circuit. C is initially uncharged. Switch is closed. After the long time, capacitor has a charge Q. This is the KVL equation. E minus R into I minus Q upon C equal to 0. dq by dt is a current. So if you look at this equation, this is first order linear differential equation. When we solve this equation, we get the charge Q. This is equal to QF multiplied by 1 minus e to the power minus t by RC. RC is equal to tau. As t is equal to 0, charge on the capacitor is 0, uncharged. T tends to infinity. Charge on the capacitor is QF. Capacitor is full charge. So when we say long time, it is infinite time to acquire the full charge of the capacitor. This is shown as a charging equation. This is a charging curve. T is equal to 0. This is after 1 time constant. This is after 2 time constant. approximately after 5 time constant we will say capacitor is 99% charge. In the diagram you can see after 3 time constant this is 95% charge. So this is a way capacitor charges. So what we learned here? We learned charging and discharging of the capacitor, series and parallel combination of capacitor, and energy stored in capacitor. Thank you.